What's up, folks? Welcome back to Intuition. Today's video is another geometry video. Today we're going to continue our geometry transformations and we're going to tackle reflection. We're going to learn how to reflect a point across a straight line. We're going to be doing this for any straight line, which is going to have an equation of y equals mx, which is the equation of a straight line that passes through the origin. So you have some straight line with some slope m that passes through the origin, and we're going to reflect some random point across this line. We're going to declare this point x naught, y naught, and then we're going to ask ourselves, where will this point end up as we reflect it across this line? We figure that out by drawing a perpendicular line that connects the point to the straight line, and then we continue an equal distance past the line to the opposite side. And that's where the point is going to end up, and we're going to call it x prime naught, y prime naught. The line that connects the beginning point to the end point is going to be perpendicular to the line y equals mx. And if one line is perpendicular to another, then that means that the slope of that line is going to be the negative inverse of the first line. Our line of reflection is y equals mx, which has a slope of m. So the line that is perpendicular to that line is going to have a slope of negative 1 over m. So we can write down the equation for this line as y equals negative x over m plus b, where b is the y-intercept. And the last thing that we need to know is the intersecting point between the two lines, because the intersecting points between the two lines is the midway point between our initial position and our final position. We're going to call that midpoint x sub m, y sub m. So we want to start off with finding our midpoint, because the midpoint is the midway point between our beginning and final position. So the midpoint is where the two perpendicular lines intersect. Line 1 was y equals mx, so we have y sub m equals m times x sub m. And our second line is y sub m equals negative x sub m over m plus b, where b is the y-intercept. And we can go ahead and solve for b, because not only does our midpoint fall on the perpendicular line, but our beginning and final position points also fall on that line. So we know our initial position, which is x naught, y naught, so we can go ahead and plug that point in to solve for b. That will give us y naught equals negative x naught over m plus b. And solving for b, we get b equals y naught plus x naught over m. And now we can plug this term in for b in our y sub m equation, and this will give us y sub m equals negative x sub m minus x naught divided by m plus y naught. So we can go ahead and set our two y sub m equations equal to each other, and we get m times x sub m equal to negative x sub m minus x naught over m plus y naught. Simplifying this equation and solving for x sub m, we get x sub m equals x naught plus m times y naught divided by m squared plus 1. And since y sub m is just m times x sub m, we get y sub m equals m x naught plus m squared y naught divided by m squared plus 1. So now that we have our midpoint values, we can use our midpoint to get the final position of our beginning point. So to go from our beginning point x naught to our final point x prime naught, all we have to do is measure the distance between our midpoint and our beginning point, which is x naught minus x sub m. And all we have to do is take that difference and subtract it from x sub m, because our final position is going to be the same distance away from x sub m, but in the opposite direction. So we get x sub m minus x naught minus x sub m. And when we simplify this, we get 2x sub m minus x naught. And likewise for y prime naught, which is our final y position, that's going to be equal to 2y sub m minus y naught. All right, and then when we go ahead and substitute our equations for x sub m and y sub m, we get these two equations here, which says x prime naught is equal to 1 minus m squared times x naught plus 2m y naught divided by m squared plus 1. And for y prime naught, we get y prime naught is equal to 2m x naught minus 1 minus m squared times y naught divided by m squared plus 1. And these are our two equations that tells us how to reflect a point across a line of slope m that passes through the origin. So now that we have these two equations, we're ready to answer a question. So let's get it. This question says, after reflecting the triangle in figure 1 across the line y equals minus 2x minus 5, what are the new coordinates a prime, b prime, c prime for the ABC triangle? We're going to reflect this triangle across this line y equals minus 2x minus 5. Now this line does not pass through the origin, and the equations that we solved for were equations that allowed us to reflect across a line that passed through the origin. So what we would have to do in this case is to shift this line up by a unit of 5. Once we shift this line up by a unit of 5, it's going to pass through the origin. So we're going to shift our entire system up by a unit of 5, reflect our triangle, and then shift things back down. So let's go ahead and do that. So our beginning coordinates for our triangle are point A is located at 4 minus 3, point B is located at 8 minus 6, and point C is located at 4 minus 6. And we want to reflect this triangle across the equation y equals minus 2x minus 5. So we're going to shift our entire system up by unit the 5 so that our line passes through the origin. And when we do that, we get point A is going to be located at 4, 2. Point B is going to be located at 8, negative 1. And point C is going to be located at 4, negative 1. And the equation for our line is going to become y equals negative 2x. So this is y equals mx, where m is the slope and the m is equal to negative 2. And then remind ourselves of the equations that allowed us to reflect across a straight line passing through the origin. So for each point, we're going to go ahead and calculate our final x, which is x prime naught, and our final y, y prime naught. For point A, we're going to plug in our x naught and y naught. So plugging in 4 and 2 into the x prime naught equation gives us x prime naught equals negative 4. And then we go ahead and plug in into our y prime naught equation. We go ahead and plug in 4 and 2, but then we have to remember to subtract 5 to bring our system back down 5, because we shifted our system up 5. So we have to remember to take away 5. And when we do that, we get negative 7. So our final position for point A is A prime, which is negative 4, negative 7. And then we go ahead and do the same thing for point B, with x naught equals A and y naught equals negative 1. And when we do that, we get negative 4, negative 12. And then doing the same thing for point C, x naught equals 4, y naught equals negative 1. Plugging in those values into our equations gives us x prime naught equals negative 1.6 and y prime naught equals negative 8.8. And these are going to be our final positions. And if you want to, you can go ahead and plot our beginning and our final positions. And this is what it will look like. So our triangle was initially in quadrant 3. And when we reflected it across the straight line, its mirror image ended up in quadrant number 3. All right, and when we go ahead and look at the answer choices, we clearly see that the correct answer is answer choice A. Point A is negative 4, negative 7. Point B ended up at negative 4, negative 12. And point C ended up at negative 1.6, negative 8.8. All right, and that's our final answer. So this was definitely a more advanced geometry type question. So hopefully it gave you good practice and helped to develop your skills. So let me know if that was helpful. If it was, go ahead and give the video a like. If you have any questions, go ahead and leave it in the comment section below. And as always, I look forward to seeing you guys in the next one. All right, take care. Bye-bye.